Okay, welcome back. So we continue our journey with the presentation of Stelian from the Cluj School and Cluj University. So Stelian, floor is yours.
Yeah, thank you very much, Dennis. First of all, I really appreciate your initiative to have this workshop, and I like to salute all the attendees, those in the amphitheater and those that are online with us. I prepare a presentation about how we can shape the future of trees with AI. My feeling is that in this context, we'll have a kind of democratization of trees, because many people have seen trees as a very complicated instrument of doing innovation, but my feeling is with AI we can help a lot to expand the pool of users and people interested to use trees, as well as I like to open the door for new spaces of exploration with this tool. I will start with a slight introduction about our history, and then we'll jump to the present and see our pioneering activities in AI and trees. But last night I have thought, being here in France, to challenge the audience, because I said, people were inventive all the time, and we had challenges to face with. And I just wanted to say what would be for Gustave Eiffel some 100 years more than 100 years ago, 150 years ago, how would he design the Tour Eiffel, having trees and having the power of computation of nowadays tools and nowadays artificial intelligence algorithm. I wanted to keep in mind that we have to consider the same technologies as they knew in the 19th century. And I was just curious to see how the Tour Eiffel would look like if trees were one of the tools used by Gustave Eiffel or by the engineers that time. I didn't investigate too much. I just said, okay, let's use two important principles that I have seen some drawbacks in the Tour Eiffel, such as the stability of the height, of the tower, and some functionalities. And I have realized that segmentation and copying, if we expand a little bit this important principle of trees, could bring higher potential for this construction. Even for aesthetic, if we push a little bit more on the asymmetry principle from trees. But of course, this is a hard work. Nowadays, with the use of AI, we can very fast operate with such principles and generate creative ideas. And if you are interested, I can show you some results that have been generated of AI, and you are here after that to comment on them. So these are some results about a possible design of Tour Eiffel some 150 years ago, if those or these tools would be at that time present to engineers. It's a kind of with these tools, we have a much stronger capacity in a most accelerated way to do interesting things and to take decisions. It's not necessary to have one single solution, because in a complex system there is no one single solution to a problem, and this is important for us to keep in mind. There is not necessarily an optimal solution, but a list of close to optimal solution, because this is complexity in fact. And even if you are looking around the AI systems, they are not perfect. They are systems that can help us. We people are not perfect. We created things And now everything which is in trees is nothing else than the capacity of ourselves to extract, based on empirical activities, our way of thinking, our way of creating things. So I'm curious to see position to use our patterns of thinking and generate something that is useful for us. In my presentation, I have a lot of slides, but I will not stop on all of them. Maybe on some of them. I introduce a little bit our, let's say, history on using trees in our university, using artificial intelligence in design engineering, and from here you can expect that a certain moment we try to combine the expertise in the two fields and trying to pioneer AI in trees. And beyond our, let's say, work, I like also to introduce you a vision about how we can advance with trees by using AI and to set up some conclusions. We have started using trees in 1998 in the Department of Design Engineering Robotics, especially the field of intelligent robotics and the innovation engineering. A short retrospective about our journey in structure innovation. We have seen trees as a strong methodology to push the plausible possible beyond. And encouraged by this, we have started to work on different methods, on different methodologies. The beginning, we use trees just to integrate with different other methods in product design, as you can see there. And then we have slightly starting to investigate new tools for ideation, for structure, concept formulation, and to combine trees with other ideation tools, also to fundament the theory for competitive engineering and road mapping. Then starting slightly to handle complexity in design. In this respect, generating new tools for handling this complexity, and of course, embedded in these tools, we have seen the potential for trees, framework and methodologies, as well as with customization of trees in various other fields than the traditional ones, which have been in engineering design. Then, starting from 2007, working on knowledge modeling, semantic search, systematic problem solving for process innovation, ontologies for inventive design, etc. And since 2010, we started to explore trees for other areas than the conventional ones, especially in the business field. And after that, to invent by inspiring from trees framework, other inventive design tools to handle different systems. And after that, starting to use trees in combination with different methods from artificial intelligence with some, let's say, encouraging results. In terms of using AI in design engineering, beginning also some 20 years ago, we have started to use traditional AI tools in design, especially fuzzy logic, evolutionary algorithms, swarm intelligence, and expert systems. Then slightly moving towards the machine learning methods, especially with the application in robotics, including also ontologies with mostly application in the field of robotics. And after that, starting with 2010, we introduced the deep learning together with already, as I said, machine learning algorithms, also for the field of robotics, as well as swarm intelligence continuing to be interesting. And in terms of product design, to reduce complexity of design, we experimented principal component analysis, which is an important topic in the field of artificial intelligence and deep learning. With deep learning models, especially in the field of perception, in terms of reinforcement learning and evolutionary algorithms, the same field of application was robotics. And then we start to expand the space of investigation for product design. Thank you. Using transformers, and also we are interested in having AI models for small data, because in many applications, including product design, will not all the time benefit of big data. In design engineering also, we were concerned about combining different spaces of actions, such as creative engineering and inventive engineering, generating new methodologies where in different stages we use artificial intelligence for refining design. You have seen an algorithm for using generative adversarial networks and variational autoencoders and evolutionary algorithms to generate multiple design solutions, also to have a refinement of the design with AI, especially with models of transfer learning, with reinforcement learning, especially for design optimization. This is just an example of using this kind of methodology, using autoencoders to design a proper configuration for this robotic system. We have also a video. I don't know if it is working, but yeah, it's working, but I have to find the place for the mouse, the computer. I stopped the noise, but actually here was a challenge how to remotely control this system and which is the proper configuration to reach different spaces and feel the patient comfortable. And in order to explore a very complicated space of possibilities, we had to use to define the solution. And here we have an explanation about how we have trained the model with different possibilities in order to identify that solution, which finally has been replicated in a container to have this remote medical assistance. Another application of this methodology was starting with existing solution, how we can use AI tools in order to create new patterns of exploring the space. For example, here starting from a existing robotic arm, we apply different kind of trees principles, and using, for example, in this case, we just play with a GPT model to identify some other patterns, and you can see here the result, one of the results. Or also to create a comprehensive framework for design engineering and how, in different stages, what kind of models or AI models can be used to enhance the capacity for a mature solution. It is not necessary to use your own solution, but also it is also important to inspire to in tools available to everyone and to use the different steps of this design engineering methodology for designing complex systems. This application is in the field of pharmaceuticals. We had to design the installation and there are many complications inside those chambers in order to master the chemical processes. In this respect, as you can see, this was a research project in different steps. We have used different tools that are available in the market to valorize the capacity of AI for getting better results. About, let's say, the research, the fundamental research we have done in the field of AI in trees. We have started from the following idea that trees in principle has some generic guidelines, such as breaking psychological inertia or identifying and resolving contradictions, laws for system evolutions, better use of, or in a creative way, the resources, the ideal final result, problem formulation, knowledge and principle-based innovation, as well as substance field analysis. And in another research project, we have tried to see how we can expand traditional tools with AI. And in this respect, we have seen some possibilities of using AI in all these tools and what kind of models from AI in order to expand the space of exploration and to accelerate also the time for mature solution. So this is a kind of synthesis of what we have seen and what kind of models can be used to valorize this space. And in this respect, we have proposed a list of methods. As you can see, the first part of the list are nothing else than an expansion of these traditional trees tools by using different kind of AI models. Another area of investigation was to explore the combination of trees with, let's say, traditional AI models, so not let's say, necessary GPT or ChatGPT as a specific tool for these pre-trained transformers. How we can use contradiction matrix in combination with fuzzy logic, with swarm intelligence, evolutionary algorithms, and reinforcement learning. Or some other tools that we have developed, but in combination with these large language models, such as BART. BART is a combination of BERT and GPT using LE5 or LI5 from Hugging Face in combination with people in the loop in order to assist the ideation process. I will give you some examples in this respect, or how we can combine GANs with transformers or other methods such as long short-term memory with new activation functions for expanding the possibility of diverging the capacity of the models to create new things, as well as for complex applications to embed these large language models in design frameworks in order to speed up the analysis and the design process. Here I'm not going to spend too much time, but just I give you a flavor about how you can expand these traditional trees methods with AI. For example, in the contradiction matrix, of course, we have started with identification of contradictions, which is a human-made job. But then you can use AI in order to enrich the data, the content, and leverage this AI. You can expand the space from a traditional static matrix to something which is dynamic, because you can explore with AI a huge space of data. For example, BART, who is investigating Wikipedia, has access to a lot of information which is in that database, and as you will see another example, you can even identify new principles, new inventive principles that have not been before included in the traditional trees contradiction matrix. Then, of course, you can generate idea with traditional trees, and if you consider a continuous process where you enrich the database with more and more information, of course, we expect to have an improved capacity for contradiction analysis or tackling. The same with other tools like analyzing different resources from physics, from chemistry, to have people be finding to the very ground base how to tackle with complex problems. Also, you can use AI in relation with ideal final result to set up visions and to measure the gaps with respect to, let's say, a very mature solution using the backcasting approach. Here's an example of a tool we call Cobra, which is about breaking down the initial, the psychological initial people and putting them in situations where they can expand the space of exploration. Of course, here using reinforcement learning, you can improve over time the possibility. This is dynamic contradiction analyzing, etc. So I will pass fast a little bit on this tool because there are many examples, but in principle, which I like to say or to conclude is that in terms of trees future, we have a huge space to explore and to enrich these methods, these traditional methods, with more and more data being facilitated by AI system and the knowledge bases in order to enhance the possibilities for being more creative and also to democratize these tools to be accessible to a wider pool of users. The substance field, which is very complicated for many people, not very often used by means of AI. We have the possibility to analyze different standards and introducing information about systems, about fields, about substance in components. We can use these systems, AI systems, to support us in modeling the space of analysis. These are tools that integrate other methods in a more comprehensive methodologies by means of AI, as well as this one. Faster. Here I just give a very basic problem-solving algorithm because GPT-4 and ChatGPT maybe it's interest of many people. Yes, even this system can be used in combination with trees. If you put everything in a well structured algorithm, starting with the identification of the problem, generate design idea using, for example, ChatGPT, evaluate design alternatives, this time with trees, to refine the design with the support of trees, and then also with the support of trees to define the optimal solution. And here, in fact, systems can be used to explore the space of possibilities, to search for possible solutions that are in their database by directing the search according to different inventive principles generated from analysis with trees. This is a kind of roadmap define the problem, going to the root cause, defining the ideal final result, defining the list of multiple constraints, and based on them, such as ChatGPT, you can define some ideas. You have to, of course, to analyze by an expert in a critical way. This means to evaluate the design with trees and then to apply the trees guidelines again in the system to refine the design. This makes possible to generate different variants in a much faster way. And then, of course, by defining different optimization criteria, you can analyze the results against the guidelines initially defined by trees. So this is an example where engineers can combine available tools with trees in a friendly way to solve their problems. And this is a kind of example we have used for using that algorithm. And you can see we had the need for a special gripper to handle very fragile object, but a variety of objects as shapes and dimensions. And I gave you a link where you can see exactly with that roadmap to generate the solution for the gripper, which is a little bit conventional. I insist, and was mentioned so by our colleagues before, that we should not see AI as a large language model only. So we can use many other AI related methods in combination with trees to enhance our work. This is a use case, simple one, just better chair for the office, but using trees and fuzzy logic. Or in this case, how we can use swarm intelligence with trees to optimize another problem, the traffic management in a smart city. We run several projects on smart city in Cluj IT cluster, which I'm also leading, and there we applied this for solving a problem in one of our cities, or to design the next generation of an airplane, but in this case using evolutionary algorithm in combination with trees. This is with reinforcement learning to automate the operation in a warehouse. So this is related with an Industry 4.0 project we had. And now a little bit go into more details, technical aspects, where we developed an algorithm before knowing that ChatGPT will be in the market, where we had to solve a complex problem in the oil gas industry to define a solution for cleaning these tanks from garbage, which is deposited the bottom of these tanks. And in this respect, we developed a tool using the so-called neuro-symbolic AI. What does it mean? It means that we combine the human expertise with an automatic tool that uses AI models in order to, in most cycles, in order to find out or to propose an innovative solution. In this case, we used BART, which is a kind of large language model, but it's better combined, as I said, with GPT. In that time was GPT-2. But now we can use GPT-4 with no problem. And a tool that was developed by us some years ago, but is rated or inspired by trees. You can see this is a kind of architecture where we collect data from Wikipedia, and we have a document retriever. We formulate the question in a natural way. As ChatGPT, BART is capable to generate understandable formulation of the outputs. And of course, we have implemented the code in Python for working with this, we had to work exactly like in natural language processing to track the information and put them in supporting documents. This is the algorithm. Everywhere you see it's about a human in the loop. So in different stages, we had the expert who is going to intervene in the answers provided by the system, adding maybe new insights, asking again to search for solutions. In this respect, we are open to use any kind of principles to search, but we had an algorithm in 10 stages to make this search. This is the way we describe the problem. This is the way in the middle to describe the system, and to the end, to the right side of the slide is to describe the target result. Of course, this information are entered as inputs in the system, and these are, let's say, illustrations of how the AI system replaced to our questions. Every step you can see here, 1, 2, 3, etc., are different iterations and altering or interventions also of the human expert in the loop. Besides these recommendations, the system is also capable to extract relevant data about technologies or about scientific principles that we can use to inspire in defining the solution. And this is a schematic of the final idea of the technology we have developed. This is another project where we try to create new architectures for inventive design by designing new activation functions. Our colleagues told us about the last layers, which are dense layers. So in those layers, we introduced 10 layers with specific activation functions and special generative adversarial networks in order to create new ideas. This is an example using small data to create new things. This is another interesting example for complex system design where we had this kind of problem to introduce these wires into holes with robotic systems. Starting from a generic definition of the system and the KPIs, I'm not talking about the process, we extracted these KPIs here, but we can generate a flow. In this flow, we had about 84 steps and 84 contradictions we had to solve, but with the use, in this case, I gave you the example with ChatGPT, very simple, in 5 minutes, we introduce these algorithms and generate all the combinations, and very fast we have solved the problem. But it's about 25 pages of outputs, but finally got, here's the cat, because this is very recent project we released, how to solve this problem. Okay, I have here a vision about advancing trees with AI. In relation with large language models, and integrate AI in trees, including, and this I like to say here, personalized trees learning and global collaboration. And this is very important in terms of global collaboration we can explore beside other, let's say, maybe more expected areas of exploitation, but also how we can advance with AI in order to enhance the ideation or automating contradiction analysis, even strengthening the arrays methodology, expanding the knowledge base, and including trees or developing trees for new fields. For non-large language models, here are the areas. Traditional machine learning, but also NLP and resolution, etc. And something which I like to end with my presentation is, you know that in the contradiction matrix of trees, we have a lot of black boxes. And here it's an example how I use an AI model to identify principles, inventive principle for one of the black box, speed versus reliability. You see, one aspect is that I identified that principles from trees that have not been yet introduced there can be used, because now we have examples in this respect, but also integrate redundancy. It's a new kind of principle that I have discovered from the commercial aircraft, for example, or the others. Also, nested door, for example, is from the field of IT. So the idea is we can explore large spaces of use cases and extract the generic aspects in these use cases in order to expand the matrix of contradiction. Conclusions. Yeah. I think the future is bright. I mean, at least I'm confident that in the next 10 years, we have no problem to explore new spaces of trees and AI. And I'm really happy about also the future of Atria Trees Future Conference in this respect. Thank you very much, Denis, for offering me this opportunity for presenting our work.
Thank you. Thank you, Stelian. So next time I invite you not only a day, but 3 weeks. Okay. Or what we've seen. Okay. No, because if we want to take one by one each item you brought to the screen, that's a 2-year activity. Yeah. When you build a roadmap for the next 200 years here. Okay.
So it is my job as the current president to give an inspiration.
Yeah.
Also for future.
That's so. Hopefully the sequence has been recorded, so we will take time to carefully play on stop and read.
Thank you.
Thank you very much. So we have time only for two, 3 questions, both audience and online. So, Nasser, you want? Yeah, you need to speak in a microphone in order for distant people to hear your question.
First of all, thank you for your presentation. It was very wide range and I see a lot of information. About the ontology part, how do you think we can use the ontology to solve the contradiction?
Ontologies, ontologies, it's about modeling a space, yeah, a system. Okay, ontologies are based on human expertise.
Mm-hmm.
In an ontology that can be useful, but ontologies, from my opinion, are very useful now in relation with this use space of collective intelligence, such as ChatGPT, for example, to introduce ontologies in the prompt, in interacting with such systems in order to investigate different searching patterns. And in this respect, I'm very sure that you will have the opportunity to bring some good ideas to solve contradictions.
But my question is, what is the difference between ontology and, for example, graph of knowledge?
It's, let's say, not necessarily a huge ontology. It's not a huge difference, but the graph of knowledge, finally, an ontology. But when you put the graph in from the perspective of AI or new models of deep learning, that's a kind of difference, because you have to deal with every node, what context this node. It's about explanation of the context awareness. This is where the machine ontology is not necessarily learning about context or system. It's rather than defining the system, describing the system.
Okay. And in your methodology, I saw you say, for example, we evaluate the design by trees or verify result with ChatGPT 4. But in my mind, to evaluation, we should use some simulation, or we build the model to see its work or not. How you evaluate?
It depends. Depends. There are different types of assessments. There are qualitative assessments where you can use these empirical approaches, such as inventive principles, to relate with, or maybe other laws of system evolution. And as in one of my presentation, I put, and this is important, where you combine trees with non-language models, so something else than language models, where you can include simulations, and that was one of the use cases where, in order to optimize the system, you have to use simulation. So that's an important aspect. In these days, even simulations as a proof of validity of some results are very important, and we should not neglect simulations and modeling. Agent-based modeling, it's also very powerful to express for complex systems, for example.
Okay, thank you.
I have seen one question in the chat was about the presence of the slides, but I believe each presentation you will give me back the PDF of your slides, and I will diffuse to all the audience through the webinar address the PDF of each presenter. Just to let everybody knows, it's also a recorded session, so we will cut each presentation in order to remove the coffee breaks, etc. And we will only put the recorded individual presentations of the whole day. Okay. So this is to answer the chat questions I see here. One more questions before we switch to the next presentation, which will be the last for this morning.
Thank you for your presentation. My question is how we can use this work. Are there any software or any open source of your works?
Some of the algorithms are, let's say, with coded, not necessarily as advanced software, but if you know programming, you can use. We can talk and exchange information about this. For example, the one where you use new activation functions.
But is it online on a server available, or is it only?
I did not upload it, but if there are people interested, we can share this.
Okay.
No problem.
Thank you. So thank you very much, Stelian, for this very dense presentation. So we switch to Davide. No, it's sorry. That's this is afternoon. Yeah, this is Pavel's time, who will bring us from the end of the morning to the lunchtime.